Good afternoon, everyone, and welcome to the second expert panel. This one is very focused on entrepreneurship, especially innovations that are powering green transition. So in the morning, we had professors and policymakers talking about green transition. Today, we have people who are actually operating at the bleeding edge of technology, people who are pushing technology and innovation to make green transition happen. So today we have with us three entrepreneurs. Dr. Akshay Jain, he's the co-founder and CEO of Cancrie, and it's a pioneering clean technology, and it's working on transforming agri-waste into advanced carbon nanomaterials for next generation energy storage. So by energy storage, is it utility grade batteries that we're talking? So batteries. So essentially the raw material and ingredients that go into the making of utility scale batteries, carbon and nanotubes is one such raw material which they are generating from agri waste. So that's a very interesting innovation. Welcome, Dr. Jain. Thank you so much. We have Mr. Avinash Kumar. He's the founder and CEO of LivNSense GreenOps. It's a Bangalore-based climate tech company enabling heavy industries to decarbonize. And we were just having a conversation over lunch. They use a lot of artificial intelligence and ground sensing using IoT technology to make that transition happen. And I think it's a very significant area because decarbonization of heavy industry is a low-hanging fruit, but also a difficult-to-grab fruit. So multiple complexities. And glad to be hosting Avinash Kumar over for the conference. Thank you so much for joining. And our third panelist is Mr. Tanmay Pandya. And thank you, Tanmay, for joining. Again, we got the honor and privilege of having a discussion over lunch. And he mentioned that his company also is focusing on the agri-waste side. How can you convert the agri-waste into value-added intermediary products, especially carbon and carbon-related products, into various. Essentially, it's a sustainable materials innovation that we are having. So we have two materials innovation on the panel, and we have a process innovation as a third panelist. So what I would also, people who are joining us online, I would like to brief them that this is going to be a free-flow conversation, but we will start with each of the panelists talking a little bit about what they are doing in the first place. Right? What is the, why would you do that? Is there a need for that technology? Are you really filling a gap? What is the business potential for this? And then we will start talking a little bit about their own entrepreneurial journey. And for researchers out there, we will also see if there are opportunities for you to explore any research projects in what they're doing, both technical as well as the managerial and management science part of what they're doing. So that is going to be the brief. We will have a conversation for around an hour, starting with all of you presenting about yourself. So let me invite the panelists onto the stage, Dr. Akshay Jain, Mr. Avinash Kumar, and Mr. Pandya. Welcome. It's easy to start in an order. Maybe I can just start from over there. And so, Tanmay, what do you do?
Sure, so I explain. So, hello everyone, I am Tanmay. I am a founder of Brisil Technologies. So what we do? So what, in one line, we take a fly ash and convert into chemicals so that they can be used in various applications. Now I'll explain. So we all eat rice. We all know.
People may want to know what is fly ash.
Yeah, that's what I'm coming to. So when we use the rice, when it's produced, it has a covering which is called husk, which is now used as a biofuel to generate either electricity or to generate steam in the industries. And when we use this biofuel to generate energy, eventually the biofuel would be burnt in furnace. And when you burn it, we will get the ash. Now what happens that the companies which are burning this rice husk, they generate huge amount of ash. Like very near to Ahmedabad, there is an area called Bawla. In Bawla, every day 300 to 500 tons of rice husk ash is generated, which you do not know, but is being dumped somewhere around nearby in open areas. And during winters, it flies with the air. We can't see because the particle size is very low, but it increases the AQI. And if you check Ahmedabad's AQI today, I am sure it is around 200 or 300. So this waste is all being dumped, and Ahmedabad or Gujarat is one of the low rice producing regions in India. If we talk about the major regions like North India, South India, the amount of ash which is generated and dumped is very high. What we do is that we take that ash, use our chemical process, which is a patented process where ash is mixed with some chemical and all, and we get some products. One product is called silica and one product is called activated carbon. Majorly we get silica, around 70 to 80% of the ash weight we get silica. So what we are doing, rather than letting go this ash into environment, we directly work with these companies so that when the ash is generated from their furnace, they pack it and supply to our factory. We use our chemical process. We get silica. Silica is a very important material in our day-to-day life, and we supply to its user. So the question is, what is silica? So silica is kind of a raw material for various industries.
Silica is in sand, right? The silicon dioxide.
Yeah, it's a silicon dioxide, but different form of silicon dioxide. If you are using a salt every day, you have seen that ad that, it was I think few years back where you used to see that chip-chipa namak and free-flowing namak.
Free-flowing namak, right.
So that free-flowingness comes because of silica. Similarly, all the toothpaste we use, it has silica. If you are wearing sports shoes, and then you are using silica in sports shoes as well. So it is a key raw material for tire, rubber, toothpaste, food, paints, coatings, medicines we take. So everywhere it is used. What we have done is that so far this all silica was coming from river mine sand. The sand is converted into silica, and this river mining happens sometime legally, sometime illegally.
Mostly illegally.
Mostly it's illegal in India. Some countries it is allowed, but mostly it is illegal. So all of this silica was coming from this illegal method. What we have done is that found a new method where a waste can be converted into this silica. And we have been able to develop and commercialize this technology. We have a commercial scale plant operational in Gujarat near Vadodara. And currently we are supplying to some of the global brands like Adidas, Decathlon, Seat Tires, BKT, and some customers in Europe, US, everywhere. So that's a brief of work I do.
Thank you, Tanmay. Thank you so much for describing, from end to end and with such clarity. Thank you so much. Ashwin.
Yeah. Hi, my name is Avinash Kumar. So I'm the founder and CEO of LivNSense. LivNSense is essentially, we are an AI-driven decarbonization company. So let me just explain, give a background what we are doing it. So we are leveraging data, or the I could call it more like a private data from the plants to utilize the understanding of energy consumption and process emission, which is process emission happens because of the process efficiency issues. The fundamental things why we started doing that, because when we got into this decarbonization, everyone was talking about energy. Energy is your input fuel. And you can only do a control of the input fuel, whether it is gas or it is liquid fuel, to certain level. Maybe you can make it more optimized, you can reduce the wastages and go up to like 20-25% efficiency, but beyond that, there's not much scope. What happens is, fundamentally, when we started working with these heavy industries, and I'll just like to give you the example of heavy industries like cement manufacturing, it could be oil and gas, steel plants, etc. Total, if you see the contribution of the carbon emission in the atmosphere, the CO2 plus the other SOx, NOx, and CO, etc., it is like 60% of this emission comes from these industries. It is called GHG intensity, greenhouse gas emission, and why GHG is more important than even the vehicle pollution, because what happens is your greenhouse gas emission is all about what it gets into the atmosphere and it stays there. It continues to stay there. There is no way you can take it out from the atmosphere unless you find some form of acid rains and all, which happens eventually, and that is how serious it is. The problem is very serious because finally this is what it is cutting down your ozone layer, everything it is responsible for. So that's what we are trying to help cut down the foundation of this GHG emission itself. To do that, initially our focus was on energy. Definitely we also started looking how to reduce the gas consumption, how to reduce the fuel consumption by eliminating the waste. And to do that, we started using the data from the plant. The plant already has got so much of data. Unfortunately, it is not utilized in real time. It is not analyzed in real time. The variations which happens in real time is not controlled today because that is left to the operator or the skilled operator sitting in the room who can take all these dynamic decisions. Because most of the control systems which is existing today can work on physics or rule-based models today. So that is what the challenge or gap in this. So when we started off, our journey was to look into the input fuel, and then we got into the process efficiency part. Because we started seeing that what the plant has been configured at versus what it is operating over a period of time, degradation happens. So degradation can happen due to multiple reasons, from the equipment, from the degradation of machines, from the change in the process behavior. And it is very difficult to capture that unless you have somebody in real time reading every data and trying to understand those variations. So that is where we started developing the first layer of foundation models or algorithms, you call it, for the AI to start capturing those data and start understanding those abnormal behavior. Now those behavior can happen once in a while, it can happen continuously. That is where the whole challenge is. How much you can understand those, how much data you have, and that's what will give to the accuracy level. Today, just to give the few examples here, you would have seen steel plants, essentially, they are having a biggest challenge of their yield and the waste. And when you talk about the waste, when whatever is not good quality, that goes as a waste. There is a solid waste, and there is a lighter particle which goes into the air, which is called the GHG emission, whether it is CO2, SOx, NOx, all the various particles. Now, what we are trying to help them to understand the profile of the coal as it is going on to the conveyor belt. We are trying to capture those. There's a various parameters, like, for example, what is the hard core grindability index, for example. That is called AGI index of the coal. If you know that, then you know that how good is the coal in terms of giving the calorific value versus the waste. So this is very important factor to understand as it is going, because the lab checks only is done on a batch wise. It is never done on a continuous basis. So giving that more accurate granular result will help them to optimize their process better and cut down the emission. And that is what today is needed. In fact, these industries can cut down their carbon emission by almost 25% by utilizing these technologies, even before they adopt to the high capital cost solutions like CCUS, carbon capture, or green hydrogen, which is going to be in future. So this is what we are doing. We have been now in US, in India, as well as now we are expanding in UAE as well. In US, pretty much our focus is more to how to provide them energy efficiency, because still the carbon part is still not very clear there. But then when it comes to UAE and India, we have started giving them the actual reduction in carbon in terms of the CO2, SOx, NOx, and various things. And as we have been evolving our processes and technology, we also realized that in future, when you start using the alternate fuel, so For example, we talked about the biofuel. Now, slowly the cement companies have started utilizing a form of biofuel. They have been using agri-waste, they have been using animal waste, they have been using most of the, in fact, the new technology which we are seeing, they might also use the demolished materials as well as part of this one. So that's what we are also going to work on. So now to make sure that there is a good optimized mix between the alternate fuel versus the traditional fuel is very critical, because you can't change the processes suddenly for this industrial. The only way is to identify what should be the optimum mix and make a very accurate decision on the calorific value so that their downstream processes doesn't get impacted. And that is what we are doing it. Today the impact is like we are impacting the bottom line. The bottom line impact, like for in US when we work with the asphalt companies, we have reduced their wastages, which is in the average of 5% of the waste, to almost we have brought down to less than 2% now. So that is directly benefiting them, apart from the carbon efficiency and energy reduction by the reduction in form of the gas consumption, etc. So that's what we are doing. So it is profitable and for the industries, so they can pay out of their P&L. That's what we do. Thank you.
Thank you, Avinash. Thank you so much. We'll come back for the next round. Over to you, Akshay.
Hello everyone, I'm Akshay, co-founder CEO at Cancrie. So I am a chemical engineer and I did my PhD into the similar area what we are building at Cancrie. So first of all, let's understand what's Cancrie. So there we will get an idea that why and what we are doing. So Cancrie was or is a name of a planet, which was found in the year 2004 by NASA. And this planet is entirely made up of very high quality carbons. What are those carbons? Graphite, diamonds, graphenes, all those very high quality carbons.
So high quality means the crystal structure or purity?
Purity levels.
Purity
and
levels.
also of course the crystals.
Crystal
As in we get these crystals, we get high purity. Like for example graphene, right? It's black. Diamond is not a black, but still it's very pure, right? So it's something which can be used in the batteries as well. Like graphene has its own use case, graphite has its own use case. So our idea is that to make the batteries better, do we have to go all the trillion miles away to get these high quality carbons? Not really. Why? Because we found our own planet, Cancrie, on this planet Earth, where we are supplying these high quality carbons for better batteries. So that is how this term came. Now, what exactly we do in Cancrie? We are making these high quality nanocarbons. Why we are doing it and what exactly we are doing? We are focusing on battery industry. Why? I will tell you very soon. So we all know that the battery market is going up in a big way. Why? Mainly because of the rapid adoption of the EVs, renewables, all these things are coming up.
Electrification in general is...
Electrification in general.
Yeah.
And we want to move towards this greener transition. We want to get rid of, all these fossil fuel-based electricity. Can we get these from solar, winds, and can we store it in the batteries? So there's a huge demand because of these two major things, right? Now, when we're talking about these batteries, there is inherent issues with these batteries. What are these inherent issues? Number one, there is a lot of, you have seen there's a lot of explosions which happens, particularly with the lithium. Secondly, lower efficiencies of the batteries, which means, how much can you store? Thirdly, the life of these batteries. We want more and more and more. Nobody is ever satisfied with the life of the batteries. So because of these inherent issues in the batteries, we need to innovate something so that we can make these batteries better. That's the whole idea and that's the problem statement we are working on. And that is where exactly Cancrie comes in. Cancrie is making these nanocarbons from the agri-waste. It's a patented process. We particularly using coconut shell waste, but we have tried more than 15 different kinds. Coconut shells, coconut husks, sugarcane bagasse, paper waste, human hair, chicken poop, municipal sewage, multiple other wastes. This waste, when undergoes our patented process, we get these high quality nanocarbons. This is what Cancrie does, that's it. Conversion of the waste to the nanocarbons, and that's it. After that, we just supply it to the battery manufacturers. When they integrate these nanocarbons in their batteries, they get high performance. That's it. So we give this material to them, they integrate in the batteries and make it better.
Any kind of battery, or is it specific?
Yes. So now coming to that. We can use it in multiple battery types. What we've already tried, or rather commercialized, is lead acid, because this is a ready market for us. 4,000 plus battery manufacturers are there in India. We have also done a lot of field trials for lithium. We are very close with lithium as well. Much more results than lead, but market is not ready yet in India. The cell manufacturers are not there. So lead and lithium, we are very close. Lead is already commercialized. Third comes sodium ion, where India is now trying to make a leap and pushing sodium ion technologies. Redox flow batteries, fuel cells, zinc gel, all these things we can use our carbon in a different way, in a different form. We have tried with all these. We have solid results. We have 4 patents with Cancrie now. And why we are so special and what is not there in the market is mainly because of few parameters which makes it special. So we have tweaked these parameters in the carbons in terms of its surface areas, pore volumes, pore sizes, conductivity, functionalities, particle sizes, purity levels. There are 7 parameters which we play with. All these 7 parameters are very important for the batteries to perform. So that is what we do. Then we have proven it for the results in lead acid batteries, did a lot of results, did make these batteries with the industrial players.
What's the electrochemistry? Like, how does carbon play a role? Is it like a...
Right. See, when it goes inside the electrode, what we do is very simple. Whenever any battery has to perform better, the electrolyte tends to penetrate inside the electrode for the better reaction. As simple as that. The electrolyte should enter into the electrolyte in a more efficient way. What we do is very simple. We integrate our material in the electrodes in such a way that when electrolyte or the acid inside the batteries wants to enter inside these electrodes for the better reaction, it paves the way. How? By increasing the conductivity, by increasing the pore volumes, pore sizes, surface areas. By all these parameters, the electrolyte now can enter inside the electrode much better way. It increases the wettability of the electrode, and therefore the active utilization of the electrode increases, which means like now you can make these batteries for a better use.
Right.
So what we have seen just now, cutting short, we have tried with lead acid batteries, now supplying to multiple battery manufacturers. Now we are also working with the lithium ion batteries, where we are also collaborating with big players in India and abroad. And of course the battery manufacturers directly, and OEMs as well, OEMs for the automotive sector. So we are working with all those people. The advantages, as I said, like there are multiple advantages when it comes to lead acid in terms of its life, in terms of its, how much output we are getting out of one batteries. So all these kind of results we have gotten. We have our plant in Jaipur, Ramchandra industrial area. That is where we are located. And now we have this capacity to cater around 1 lakh batteries a month, which is recent happening. Before that, we were approximately 1/10 of it. But now we have this capacity. But I would say the major task has started now. To look for the customers to sell the product is the main thing. That's what we are realizing. Product, of course, we put a lot of efforts for almost 8 to 10 years, but now the real time starts when it comes to sales. So all the efforts are in that direction. Thank you so much.
Thank you so much, Akshay. I think that's a good starting segue to the business side of whatever startups, ideas that you're working on. But before we move to business, I thought it will be useful to look at you as an entrepreneur first, and then we talk about the business. For instance, let's say Tanmay looked at rice husk. I mean, there's a lot of agri waste, but he's looking at rice husk. Why rice husk and why silica? And there could be some reason why you shortlisted saying this is where I want to focus on, right? You looked at same agri waste and you said ki carbon nanotubes, right? There's a different line of thinking. And Avnish, you said कि नहीं इन दोनों को काम करने दो. I will focus on how to optimize the processes that they are working with. So, like to know a little bit of backstory which led all the way up to this point where you're saying कि silica process optimization and carbon nanotubes. Tanmay.
So, in our story, most of things happen because of, we can say, luck or whatever you can call it. So, how did we learn about this problem? So, what we were trying to do before getting into this is trying to get some problem to solve, to see if there is any problem which we can find, which can be scalable and can be good for society, environment, and at the same time if we can earn some money out of it. So the story is that we came across one power generation company. Before that there were many other things which we were working on, but for this we came across one power generation company. Their CEO or founder happened to be our college alumnus. So he suggested that, look,
Husk power? Is it?
Husk power system. So they were using husk and generating electricity out of it. Now when they started, the husk was available free of cost. And as always happens with this such kind of material or the waste, when people realize that it has some value, the supplier start asking for the value. And eventually the price of husk at that time went to around 1 or 2 rupees a kg, and the electricity which they were generating become unviable. So they said that, look, in the process we generate the ash, can you do something with it? Can you find some solution, some value, so that at least we can monetize it and we can
One more revenue stream.
One more revenue stream, and our overall cost will come down. Effective cost for electricity will come down. This is how I learned about this problem. We studied something, tried to find out what is in the ash. So we realized that this ash has a silica. So whenever such problems come, the first question is generally asked is, why somebody else hasn't done it yet? There must be some reason. And we realized that, okay, maybe the husk was a waste till few years back. So there was no ash. Because there was no ash, there was no problem. But now, because people realize that husk is a fuel, there is an ash. So it's a new problem. That's why somebody hasn't looked at it. So we did some research, found out that this ash has a chemical called silica, and ash had almost 85-90% of silica, which is huge.
It's actually a big problem when you try to, husk power might be facing this because silica is also abrasive.
So their machinery, their
starts,
machinery gets lots of maintenance problem because it's abrasive. So because husk also has silica, ash also has silica, so in the process they get lots of such problems. So this is how we found silica, and then we did some market research. I had a background in market research and consultancy, so I knew we need to identify what is silica, the market research and all. This is how I got into this. We realized that silica is a good product to manufacture. We didn't know how big the market would be for rice husk silica. We knew silica has a good market, and if we make another source of silica, it could be good for industry. We developed the technology. So first phase is that when you find something like this, you try to develop in the lab. You make it in the lab, then you try to make it a small pilot. When you make it at the pilot level, you go to some customer to see कि बन तो जाएगा, कोई खरीदने वाला भी चाहिए. So we went across companies. Fortunately, I met one person from a very big, like one of the largest tire companies in the world, one of the senior director. And just like this conference, I told him that you are using silica and you are making tires, and look, we have found something new, and we are making this from rice husk, which is a new thing, and it has advantage of carbon emission and all. And that gentleman said, okay, just send me a mail. And I just sent the mail to him explaining everything. And then I don't know what happened, and somebody from his office called that we would like to see what you have done. And that gentleman came from USA to see a very small pilot, like smaller than this area. And then we realized, he suggested to us that the tire company, his tire company, his words were that his tire company uses in 1 year what I am going to make in my entire life. So that's such a big problem this is. And if we can make it from rice husk, they would be happy to partner in whichever way possible. So that's in your entrepreneur journey, till that time, you're always full of doubts. Whether chalega ki nahi chalega, should we do it, should we license the technology, what to do and all the stuff. This was a point where we realized, okay, I think we should focus on this.
This will work.
It will work. There is a big guy saying, and if he's saying, then there is definitely a market. So we should focus on this thing. And this is how it was a point after which we got totally into this. Then we went to some VCs, asked for some funds. We did some pilot trial. Then we set up one factory inside a tire company in Gujarat, where we asked them that, can you give us some space to build a small factory? So they gave us around 5,000 square feet of shed on rent, and they said that whatever silica you make, if we require, we'll buy from you, and then otherwise you can sell it in the market. So we set up our first pilot plant in 2019. It became successful, and in 2022 we started working on a commercial scale plant, which became operational in 23, and then so this has been the journey.
Series of accidents.
Yeah, accidents, luck,
Happy
whatever
accidents,
you
huh?
can. Yeah, happenings. Yeah, this is how it has
Good.
been.
Very interesting. Thank you so much, Tanmay. Avnish.
Thanks. I think really interesting. So for me, it was like different journey altogether because I had spent at least close to 15, 20 years in corporate, worked with companies like Motorola and Wipro, with where I was part of a digital team which developed the today what you see household name Android TV. That time it was not even Android TV. We developed the concept of Google TV. It was before Google, it was Linux TV actually. So what I saw in my journey, because when I was Motorola, we were very proud about our radio technology. We said nobody can replace, nobody will be able to compete because our hardware is so unique. Today, in 25 years, if you see, the telecom industry doesn't have a hardware-based stations. It is all replaced by software. That is what has happened. Those are some of the learnings which I got. And the same thing happened when we started the journey for coming up with Google Linux TV. Because people were laughing at it, what is this Linux TV is all about? So they have always seen the TV as a physical object, physical thing. Even set-top box used to be like that. We said, no, we want to make it everything software driven. And that was a real challenge at that time, and no one believed, including Google was not there. We did it first with Intel, with the funding from Intel and all. In Wipro, we formed a core team to do this work. When it became successful, definitely that time, then we Google and all came into picture. So it became Google TV, and finally now it's an Android TV. But what it all gave me the learning, I was not in the manufacturing world. In fact, during my last leg, I worked in few of the manufacturing areas like oil and gas and automobile sector. I was wondering why this sector is not transitioning towards a similar kind of major disruption. Because all the while I saw it was either bit automation, and they were all focused on automation, but the center or the heart of the entire thing was the hardware product, the control systems, which was completely, I'll say that, controlled by the large OEMs, and they were having all the data, and all this data were made proprietary. So this is what the problem statement. So when we entered in this and started our company, the LivNSense has got a simple meaning that we want to make the machine to be living beings, to be intelligent enough and think and act like humans. That was our goal. So when we started initially, we got an opportunity, like again, we also went through a lot of hit and trial, the experiments. So first we started with automobile companies. We were trying to do something in the welding shop, trying to focus on energy management, gas consumption reduction for the weld shop. Not very successful. The only reason was we built a good product, but the buyers were not there to pay for the cost. Because in India, the labors were cheaper than that cost. So that didn't work. But then that's a good learning for us that we need to be really cost optimized costs. Because that's where we learned the first lessons in the financing side. That how do we build the product which is really cost effective. And what happened during the phase that I, through one of my common friend, got into one of the oil and gas major in US. And initially when they came, the problem was definitely starting from this whole automation challenges, they have multiple different automation systems, and the basic issue was the data. Whenever there used to be any deviations in the process, the amount of data that used to be there to analyze, it used to take them almost a week to figure it out what was the root cause. And to collect and download the data itself was taking a couple of days. And when we came that, we said that why can't we build a digital platform, having done that in telecom world and consumer electronics, why can't we do that the same here? So I wanted to focus on the problem of the data, because we felt this data can be real-time acquired, real-time analyzed, and you don't have to spend the time. That is how our journey started. Given that we got exposed to a very large oil and gas company, definitely we got understanding. We started seeing that this company had got almost multiple furnaces, which was working in the petrochemical plant. There are some furnaces they were doing almost like 120, 130 days of run length. Some furnaces were only running for 30, 40 days or less than 60 days. I was wondering that why it is happening and why can't they improve the performance of the other performance? What is causing this? Because you're consuming same amount of energy, you're consuming same amount of material, and then some of these degraded furnaces are consuming more energy. They are letting lot of chemicals in the air, which is CO2, SOx, NOx, various things. So that's where we started our journey with the data. We started identifying two things in the whole journey. One is commonly we would have all studied energy mass balance. That energy mass balance is the core fundamental of the thermodynamics and controlling the energy mass and how you want to keep in the equilibrium so that you achieve optimized yield, reduced wastages, and reduced emission. But the challenge is in physical world, when you want to replicate it, it is all left to the operators, because physics can do only up to a certain point, because physics is built on a mathematical and physics-based rules. And after that, it is on any kind of real-time exceptions coming is left to the operators. And those operators, we've started looking at it, is every operator has its own skill sets based on their experience. And they are controlling that knowledge. They are not giving the knowledge to others. So that's where we started thinking, why don't you make a platform that can capture every process step, every process data, understand the variations, and can correlate across the life cycle to help them not only optimize their processes, eventually reduce the energy consumption, reduce the wastages, and it started giving result around the CO2 emission, which was the first thing. But then we saw we are able to reduce the SOx, we are able to reduce CO, we are able to reduce the NO and NO2, which is much more harmful. And that's where we built our first product, and we called it GreenOps, which that's why the company name became LivNSense GreenOps. So that's the whole history. And once we had the success,
when was that? What time of the?
This was, we started almost in 2019, 2020, I'll call it 2020, because 2019 it was an idea. 2020 we started the whole engineering. We took almost 3 years to develop this product. Went up to almost close to 2023 when it became a robust product. And after that, this success in US, the first thing we did, I think, which I could also see this some of the battery challenges we were looking at, and I started recalling, we did first project in India in smelting plant. And we also figured out the same challenge, the real-time valuations in the whole smelting process is so challenging that if you can figure it out, those few parameters and get a good control over it, you can do amazing job in terms of reducing the emissions, in terms of reducing the wastages in the aluminum. So that was our second success, and that's how we moved forward. Now today we serve cement, we serve asphalt in US. In fact, we are almost scaling in a big way in asphalt plant in US. We are trying to do alternate fuels based optimization in cement, and we are trying to do the coal quality variation in the steel plants. So pretty much we have built the platform and have this so many reusable assets, algorithms created on it, that now we have cut down the cycle time of any of these requirements to customize it for any new industry use cases to less than 2 months or even less than a month in certain cases. In fact, asphalt plant, we could do it in a couple of weeks now. So that's what the power of data is there. I think it's still a long way to go. I'm not claiming that we have achieved everything, but yeah, we are seeing a good sign of growth now. That's where we are.
Thank you. That's very interesting, Avinash. I mean, you're incrementally building up, based on your corporate experience. Thank you so much. Akshay.
Yeah. So I think my journey and whatever the things we have achieved are a lot of ups and downs, but all these things started during my PhD period. So how it started was when I first met my professor. He said that, Akshay, we have one project from National Environmental Agency, and that is about, we need to do something about upcycling the waste. Not about recycling the waste, but you need to add some value to the waste, which is not a very meager addition. It has to be a real upcycling. The product should be really expensive and a lot of value should be added. So that is also the difference between upcycle and recycle. So he asked me, what can we do? This is how, when we started, we tried with different kinds of waste. Firstly, we created a lot of different products out of it. Low-cost fuels, low-cost adsorbents, what do you call this, carbons definitely was one of the products which we made at the end. But a lot of different fertilizers. So 3-4 products came out of that waste stream. But it was not something which was a lot of value addition which was coming out of it. Then after almost 1.5 years of research, we read a lot of patents, a lot of papers. Then we came out with certain product which was of very high value to the batteries. And of course, it was also an expensive product. So we hit that first, what do you call that, POC, after 1.5 years or 2 years of research. After that, I took almost 2 more years to did almost 200 plus different kinds of carbons, changing different recipes, chemicals, raw materials, many things, processes, flow rates, many things have been changed. 200 plus carbons have been produced over the next 2.5 years. And after 4.5 years of my work, we got a patent, few publications, and we got a very good product. Very good product. It was working fantastically well for lithium-ion batteries. Because PhD, nobody does lead acid, right? Because lead acid is something which is an old market. Lithium is something. So we published papers on lithium, very good results. Everything was super fantastic. Then I started working in Singapore only for a couple of years, almost 3.5, 4 years I worked there. I was also working as a consultant there. They said, like, can we do something on our own after 3.5 years? And there was definitely some support system. So I joined one of the accelerator programs there, and then, this is how the journey started. So the problem statement of our startup was very simple. We have a product in hand. The only problem was, can you make it a commercial feasible product? It was super expensive, very expensive. The kind of machines we were using, the kind of chemicals we were using, everything is fancy. You can get anything in the lab, but when it comes to commercialization, it's a different ballgame altogether. So that was the problem statement. Can you commercialize it? The same quality product, we know it works, but can you commercialize it? That was the problem statement of our startup. When we started going into the market, we initially thought, we have a fantastic product, let's go out and reach out to the players, and they'll help us, they'll fund us. When we reached out to the first player, he said that, do you have a material to try? Because nobody believes it, right? Just by looking at the results and patents and papers, nobody believes it, to be honest. They said, we want to try it before we adopt this product. I said, no, we don't have it. They said, you have to make it. So when we go to the investors, they said, where are your customers, right? How can we fund you? Do you have any traction? So that is where, this is always a chicken and egg situation where we are currently, even today, this is a situation always there, but we have to take a step. We went to a lot of other people, we got for acceleration programs, grants, and all these things happened. We found our first pilot plant, very small, we call it as a garage lab. It was 250 square feet room. We bought 2 furnaces, 1 dryers, and simple machines. And we tried to commercialize it. We bought those machines with simple MOCs, material of constructions, so that we can commercialize this product. Everything is very fancy when we use in the lab. We are using alumina tubes, right? We are using very high grade chemicals. But when it comes to commercialization, we all got commercial grade chemicals. We couldn't use alumina tubes. We bought some, stainless steel SS316, SS304, all those kind of equipments. The first product came out. We were very happy. BET surface areas and all of the things, the parameters, what we do, everything was fine. We gave the product to the battery manufacturer for the first trial. I'm talking about 2021. We gave this product to the battery manufacturers. He made the batteries out of it. Almost 2.5 months. After that, he did the testing for almost 4-5 months. Everything was fine, but he said, Akshay, there's a lot of water losses happening in my battery. We couldn't understand why the water loss is happening. So we did the own testing, and we found out that there's a lot of contamination of iron, and that led to a lot of water losses. But that also happened after almost 2 to 4 months of research. Like we couldn't know what is happening. A lot of papers, a lot of patents, we read everything, we got the material, we tested it. And what we found was that iron contamination was so much because of the MOCs we were using in the machines. So the contamination allowed is around, maybe you can go up till 20, 30 ppms. We were 20,000. That was the contamination level we had. How can we get the performances? Of course not. A big failure. After all these grants we got from the government, the projects, the customer lost everything. We were out of money. That's why I'm talking about 2021 late. Out of money, we said, okay, fine. We have applied for one of the programs called Techstars. This is the last chance we have. If we get the money, it's okay. Otherwise, we have to shut off. We were surviving on 30,000 rupees per month from the government of India, which is DST, for the company. We put a lot of our savings, but that was the time we were just waiting for things to happen. Luckily, we got some support from Techstars. That was in April 2021. We got that support. Then everything happened. Then we said that this is what we can do. We found our own mistakes, and then things happened. They said, okay, we are ready to give you the chance. We went there, were there for 6 months, came back, put up a new factory in little bigger area because we were having some funds there. Put up a bigger factory around 5,000 square feet area, changed all the machines, changed all the MOCs, and everything was, as per the expectations. It took us almost another 1 year to get the right product, and also we made these real batteries again with new customer. But this time when we made these batteries, the results what it came was fantastic. Very good results came out. No water losses was expected, same what they're getting, but very high performances in other parameters like life and all that. So that's how the journey started. Again, this we applied for grants. I'll tell you, when we went to the VCs, we were literally shooed away. Nobody gave us the money what we were asking for because it's a capex heavy business. So we all, whosoever were there in our team, we all sat together. We said, VC is not the way at the moment. We have to rely on grants, maybe a little bigger. We didn't leave any stone unturned. I'll tell you today, we have applied for almost, maybe it's approximately 90 plus grants we've applied so far. We have gotten definitely not a lot, but yeah, reasonably okay, maybe around 10, 12. But that's how we survived for almost 2 to 3 years. We did a lot of trials, went to a lot of customers. We got our first order in January 2024. That is where we again went to the customer, VCs then, that we now have the orders, you give us the money. We got our first term sheet in April 2024, got the money in December 2024, used that money, and then now putting up a plant almost there, very close to commissioning. But we know what all, challenges we face in this journey as well. But from December 2024, we moved to 25,000 square feet area where we are now expanding to 15 times what we were having in the pilot scale facility. And now the plant will be commissioning maybe sometime in maybe another 1 to 1.5 months, where we will be producing approximately 1 ton of this product per month. That's our scale. But now there's another situation where we are into in terms of finding customers. So that's always the case. Now we have this capacity. Now we are looking for more and more customers. So yeah, this is our journey, and this journey continues.
Thank you so much. That was very interesting. And Tanmay had a happier life where he got a big customer, and he had a product ready, right? So,
even in that, so with our material, we were lucky that we not only one. After that, we got many big customers.
You're happy.
But that opened the first door.
First door.
And so what we were thinking when we started is that, like he said, we will give the material. We were sure that we were perfect. We thought that we'll give the material and they will test in a week or so, and then we'll have an order coming in. But in our case also, order takes 6-8 months time, and we realized that for some companies the trial period is almost 2 years long. Because like for a tire company, it's not that they can take the material, test it and start buying. There are lots of trials, field trials, tire needs to travel for that many kilometers. So journey has been lots ups and downs, but yeah, for us it was lucky that we had customers who were willing to buy if we can make what they want.
Right. So that's, I'm also mindful of the time as we are going. So one interesting sort of question, especially from a sustainability, entrepreneurship, research, perspective, is the business model of a sustainability startup. Okay, any startup is difficult because you have to. There's a proof of concept. There's uncertainty at multiple level. So there is a requirement for an investment to stay patient for a long time, right? While this uncertainty is getting resolved. So it is difficult. But what we see is in sustainability solutions and based startups, depending upon what you do, of course. I mean, let's say what is Avinash doing, for instance, where the benefit is saved electricity or energy. It's like savings, or you are saving on carbon. There is no carbon market, right? You have carbon nanotubes. You have to show that this has commercial value, or silica that can be used in existing commercial systems. I would like to have the last closing round with your views on the business model, right? When this technology and this opportunity, when it sort of hit you, would your life would have been better if you had started some other kind of startup, not trying to save the planet and let's say carbon nanotube, you could make it something else also. Why waste, or silica, same thing, or so challenges specific to a sustainability startup from a business model perspective. If you have any insights to share with our audience.
So that's something is depend to person, like what business model we want to pursue. Because for us, we are a kind of first we had a technology. So at that time we had two potential options. One was to license the technology, go to any power generation company or any big rice mill or something and tell them that, look, you are generating this ash, we have a solution, you put your money, we can set up the plant for you, you run it, you sell it, you give us some royalty or something, that kind of a thing. So that was one potential option we had. There was another option, was to get somebody to manufacture for you. So manufacturing outsourcing, we focus only on the sales and technology, and then third option is that build everything yourself, where you get funds. And because obviously we are capex heavy, because building a one factory for us, it costs around 30-40 crore rupees. And to get that money, and even for the smaller ones, the funding is requirement is around 2-3 crore, which is not easy to get. So there were different models, but it depends on the person, what option you choose, what do you think is the potential way where you can get bigger, and at the same time, what are the funding options which you can get. So all these things were there, and it was a challenge initially, because as Akshay mentioned, VCs don't fund you until you have customers. And to get the customer, you need to have factory.
No, also to get a customer, you want something that they are willing to buy.
So willing to buy, yes.
If I sell them carbon, they will say, "Kya karenge carbon?"
Kya karenge, exactly. So for us, fortunately, we could find an innovative method where what we did is that we found a tire company who were willing to buy. So we knew, like as Akshay learned, that selling is going to be a problem, because we had many people who guided us that, it's a technology, and in the chemical technology, what you make at the lab scale, it's not going to be same at the pilot scale or commercial scale, and you are going to get a lot of issues. So first, make sure that you have somebody to take care of your sales part. So, and at that time, we could find somebody like a tire company who were willing to buy from us. and happy to give us some facility on rent. So this model helped us in reducing some cost on sales, some cost on infrastructure, and then we realized, okay, if we reduce the cost significantly in the machinery, that model is kind of a hybrid, and we can survive, and we can get to a stage where afterwards we can get some opportunity to raise funds. Because for VCs or even other bank financing or any other funding, you need to have something on ground, substantial customers buying and everything. So this is how we address this challenge, where we found somebody to buy material, get some funding from like kind of a funding from a tire company where they get us the facility for machinery, and fortunately now the government supports with some programs where you can get some soft loan or something, which we avail, and obviously there are lots of grants which you can get. Although it takes a lot of effort to get the grants, it's not easy that you apply and you get in 1 month or 2 months. Sometimes it takes years. But for us, this was what we did. The other question was that if we had gone to some other kind of a business, which is
so there was a business who was willing to share the risk of development with you from lab to prototype, the tire company,
Yes.
They
So
did a risk sharing.
yeah, it kind of, they said that, okay, we have a free space, you need to have conviction. Like it was a deal where we gave them option that if it succeed, you will have a piece of pie. Either we will give you some rights to set up the manufacturing or something. So that kind of a deal we did with them, and so they said, okay, for us, जगह खाली पड़ी है, कुछ use है ही नहीं. That was a 200 crore revenue making tire company. So for them, this small area was like, ऐसे ही पड़ा हुआ है, तुम लगा लो machinery.
Lab you tried out.
It was a shed around 5,000 square feet area. So it was like, for them it was of no use. So they said, okay, you can put it here, and you get the machinery. And fortunately for us, like we need electricity, we need steam. So all those things were available with them. So they said that we'll apply you for them. Like it is whatever they were generating in a form of waste was sufficient for us to run the factory.
Right.
So lots of pluses were there that, okay, we need to only focus on machinery, and then we can get labor from them where we can pay later, or we can adjust against the supplies. We can manage the electricity, steam against the supplies. So that was kind of in a model where we were lucky to get into, and which was very beneficial. So we don't have to worry about monthly burn or sales or expenses that were taken care of. We just needed to focus on the product and technology, and with that we got a lot of free mind space where we can work on product, get the customers on board, and work on the future expansions and all. So that is how we addressed this. It was a big challenge, and there could be other options like licensing was one option, but we didn't went into it because we were worried that in India, if you license the technology, there is a chance of technology theft. And we were not big enough to go to some foreign land like US or Europe or some countries where we can license and where the people are ethical. So that was not an option. So this is how we got into this.
Good. Thank you. Avnish, what was your business model?
Let me, I think, first of all, this sustainability, when you start anything, it's going to be a long cycle time. For us, even though it was more software-centric, data-centric, the challenges which you typically, if you go for VC funding or to VCs, they want to see that you have a very robust business model. You do have the customers, which is already at least at a certain stage where you can scale from there. So all these initial challenges are going to be, so initially we had to rely mostly on the angel funding. But one good part happened to us is what I realized in this whole journey is having a strategic customer really helps.
The oil refinery with
furnace, that is what.
Was...
So they actually really gave us initially we didn't need funding for almost like 3 years because they were paying us pretty well. So when we started, even the second year onwards, we started making a good revenue. And the revenue was good enough because one good part was being serving directly in US and having the advantage of the conversion and all you can take care of. the expenses pretty well. So that is what the initial coverage was. And then later on, we found another customer in Dallas, in Texas, and they also supported us pretty well. But if you, when it comes to funds part of it, probably we did our VC funding almost after 5 years, close to 5 years, we could do that. Because by the time we had at least 2 big, large customers with us who are doing a good, I could say, stable ARR. And that is where it all happened. So it doesn't happen in this business. What I learned is, it is the time. And again, when we have the VC now for last 2 years, one thing is challenge is how do you manage their expectation? Because you're correct, like if I would have, for example, for me being from the digital side of the world, if I would have done something in the consumer, something in retail or in the maybe fintech world, probably I would have made much faster progress and much more fortune than what we have done. And the challenges, what we go through here is also quite much. But then it is all about the passion. So it's whatever you do it for passion. Otherwise, it's not. There's no point doing in a startup. So that's the first thing. But then it's very important to keep the VC expectations as well, because they look at, compare, they will be having 5 startups, they would have probably put an investment. Definitely for them, they will not bother about the one startup is sustainability, other is fintech or what. They want to have almost the returns in similar way. And their way of return is how your valuation is growing, how your revenues are flowing faster. So here, one challenge for sustainability is it is still a business that is, I would say, slowly it is getting understood by the end users. First of all, the customer has to get to a convincing story that they can buy it, they can invest into it. Today, no one wants to do it because putting the money from P&L for a manufacturing company is not going to be possible. And that's what we learned quite early in this stage. And we started showing the improvement on their production KPIs, efficiency. We started showing on the process efficiency. And most important, the energy consumption.
And all that flows into their bottom line.
Yeah, bottom
so it is
line.
Tangible.
So tangible because they can see that their final cost of production has come down. So that is how they are able to pay. Because they will not pay anything out of anywhere else. They will not have the R&D budget. Even the R&D budget, that's for their internal purpose.
So I'm just asking out of curiosity then, what is like your model with them? Do you say that, give me a percentage of your savings? How does that work?
So when we started initially, we also started in a typical subscription model. And I was finding very hard to convince our customer. Let me worry. But even till today, in fact, the subscription, they are okay to give us the one time because they know that in next 1 year they'll be having so much of savings, so one-time cost is given. But when it comes to subscription, still that pains them a lot. So then what I did is, like when we start our journey, definitely subscription, we can't make it zero completely. We still have subscription. But in the first 1 year, we establish an ROI baseline. And for example, let's say we are cutting down the gas consumption by, let's at 1,000 BTU, which is coming close to 10% of the total cost. So what we do that is we tell them, now since this is your saving which is coming because of us, let's give at least 10% to us in form of subscription, or you give it in an yearly basis. So that model started working well because it is all about, we are trying to make them understand the impact. So the impact understanding is very important. Otherwise, plainly if I go and talk about, I am capturing so much of data, I am addressing so many KPIs, and based on that, if you start asking for subscription revenue, it's not working out. And it doesn't work today also. So this is what our transition has been. Now, I'll call it a subscription, but it is subscription is based on the actual ROI.
So identifying the value proposition for the customer, working out from their ROI,
exactly.
So what value stream you can claim.
Absolutely. And we have now done a kind of it, you can think of it like say a quick tool aspect of it, because what we do is like any new customer we get into it, we ask them, give me your historical data, whatever baseline data, so that I'll immediately create a baseline for you. And on the baseline, based on our experience and by running some of the generic models, I can tell you how much potential KPIs impact I can deliver. So that the day one itself, that expectation is set. Yeah, there could be variation of 15-20%, but that's
So you would
the
have
kind of
developed like deep expertise in specific processes?
yes,
how
that
it
is
would work.
what I talked about, the mass energy balance, that is thermodynamics.
But for specific industries,
Yes,
specific process?
we are only focusing on three industries right now. So apart from oil and gas, we have the metal, basically metal industry, which also we started recently. Otherwise, it is construction industry. So these are the three core industries.
Fantastic. Akshay, you seem to be having the greatest challenge selling your goods. So
Yeah. So yeah, absolutely. See, I'll talk about two things here. One is what you were asking about sustainability and the challenges, right? Firstly, sustainability. Really good. We making batteries efficient, reducing the mining waste because now we can use lesser of the, this active material is lesser, the e-waste generation is lesser because the life cycle is more. We are making it from agri-waste, whereas what people are currently buying is from the petroleum-based products. A lot of sustainability. But I'll tell you, the reality of the matter is, sustainability is good only if it generates dollar values to the customers. Sustainability, to be honest, I'm telling you, sustainability has no value even to the biggest of the players if you are not giving them any extra dollars. If it is same, let's say if whatever they were giving us versus what their revenue they're making or the profits they're making, if it is same, then the question comes, why do we change? We don't want to change. Even if it is sustainable, we don't want to change. Reality. I'm talking about big customers. I'm talking about big industries in US also, Heritage Group Ventures. We were part of them and they said like, Akshay, until unless you bring the dollar values to the customers, nobody will pay anything to you. So sustainability is good, of course, very good. We have to work for the planet, but we also have to think from the angle that what value will it bring in terms of dollar values to the customers.
A for-profit business model or a startup business model, if you want to make a business out of it, this should be the value that you generate from the sustainable solution. Otherwise, it has to get into a grant model, an NGO model, right? Yeah.
Absolutely. So that is where, it is extremely important to give them this value addition of sustainability, but there has to be a lot of value addition, not only in terms of, of course, you're going to give them premium quality batteries because now they can get high life of the batteries, better outputs from the batteries, better energy densities, power densities, all those kind of things you can get. But of course, if it comes through sustainability, it's good. So that is what we are also trying to do, that, sustainability together with some value addition into it. Second topic was about the hard tech and the business model we are following. We are into hard tech because we are into manufacturing. We are making these carbons, using these machines, high capex business models. Of course, sitting in India, it was a little difficult because people or the VCs tend not to put a lot of money in the capex heavy model. From the very beginning, a lot of people said, why don't you license your technology and let people invest in your technology. You be the mind behind it, but let them invest. As an investor, we are not going to invest in you. But when we reached out to those people, can you make these carbons for us? Firstly, they said, we don't have these machines because it's a very new product. Secondly, if we are going to invest in your business, then that means that is investment we have to make. Do you have customers for that? So therefore, when we reached out to them, it was very clear that we cannot have that model. We have to have our own pilot plant, prove it to them that we can make this product using these machines. We have these customers in hand, and that is where we are generating the value. But now we are getting a lot of requests, can we license your technology and make it? So that is something it's possible, but do we want to do that? That's another model. But as of now, our business model is we are manufacturing ourselves because this is a very new machines, very new model. Nobody has it in the world. Even when we reached out to China, Germany, they were not having those machines. We have to customize those machines. So therefore, as of now, our business model is very straightforward. We manufacture everything from scratch until the final product and give it to the battery manufacturers.
Awesome. I think we are dot on time. We got 10 minutes for Q&A. So thank you so much to all of you for... And now we can open up to questions. Yes, 1, 2... You have to just turn it up.
Good afternoon. Thank you so much for the insightful conversation. So my question is really about sales and marketing. So what is the strategy that you apply for sales and marketing to, attract new customers? And in that strategy, where do you place this green angle? Do you see a green premium coming into the picture when it comes to customers or let's say financiers in the conversation of that particular strategy being implemented? So it'll be great if you can comment on your sales and marketing strategy.
Yeah, sure, I can.
Yeah.
Okay.
Yeah, whatever order you want.
Now, most of big companies have a sustainability department. And what we generally do is that, generally we are selling, but they are buying. They have a purchase department. In our kind of material, generally the decision is taken by either purchase department or technical department or sustainability department. So what we do is that first we try to find out which is the right department, because it is going to be different for each type of company. And even before doing that, let's say if I'm targeting a tire industry, what I will see is that which are the tire companies who are making some noise about sustainability. Not everybody would be doing it. So first we find out who are the people who are looking into this. Then we go to we reach out to some people inside that company and see who is going to drive the decision, whether it is a purchase or technical or sustainability. And then we go to them and we try to see how can we mobilize the thing, get the trial done, who are the final decision taker, how can we communicate the value we are generating. So this is generally the model we follow. And we try to, in my experience, you need to find kind of a champion for you inside those companies. Like with the big companies, what happens that they are getting requests like us on regular basis. So most of time, even when you have approached them, it's a very good meeting and they say lots of things. And then your sample would be lying in their lab and would not be tested for 10, 15 days or month or 2 months. And even if you follow up in email or calls, it would go unanswered. So what we try to do is that we try to find out one person who can drive our work inside that company. Like that could be some purchase manager, some technical person who are actually excited about the work we are doing, so that he can drive the things like get the testing done, inform us what next we need to do, who need to reach out. So this is what we do. And as far as this green thing is concerned, it depends. Most of time now, the big organization, it generally comes from their side, that what are the green credentials you have and all the stuff. So this is how it is for us.
Thank you.
Let me answer more from a slightly more different perspective. So your first question was like, how you do the whole sales process. See, initially, whenever we start, the best way to use your the influences which you have built over your past, if you have some experience, because I use my corporate experience. I had been connected with the guys whom friend circle and all, because as I said, like without having a champion inside the company, you can't make success. So you need to figure it out. Someone is there in that CXO circle, or at least in the production head, or playing the role of the quality head. Who are the key guys who really make the decision here? So that is the strategy we took it initially, at least when we were doing the initial first few customer base. But one of the key thing I learned at that time, even now, sustainability you'll have to break down. You can't go with even if there is an ESG department, now there is a chief sustainability officer, etc. They don't have funds. So the way we broke down is how do you talk about their challenges or their pain points. So fundamentally, one of there are 3 pain points we have seen. Either they are having an efficiency issue, they want to improve their efficiency, they have the production challenges. The second is either they are having the yield issue, which is because of the waste, or they have the energy efficiency issue. So any of these 3 symptoms, once we see, we start approaching the customer to attack that problem, because we know that the end result is going to be that. In fact, you will not believe, now we have started tackling even the ESG has got an environment and safety also. There is already a well-developed department called EHS, we have started going through the safety department because we are able to attack that very easily because the safety department has got always a budget. They are much more proven in the organization and they have been rolling out a lot of new projects from there. So going from there becomes much easier. So these are the new things which we figured it out. So that's how we are now doing the stakeholder mapping, because now we are going and expanding. Definitely we can't expect everywhere we'll have our friends or some known person there. But what we are also doing in parallel, there are three influencers in the whole ecosystem. One is the system integrators who work with these companies because they're system integrators or O&M guys. Partner with them because they will be having this customer's base already. Otherwise, getting into large customer to get vendor impaneled is a very long cycle. And for us, that time is not there. That is one other thing you need to look about it. So that's what we figured it out. Second is how do you go into a scaling game plan? So this is the second one where we figured it out, OEM partnership. Now, when we talk about OEMs, like it could be Yokogawa, it could be Schneider, it could be ABB, because we have to figure it out how we complement your technology with them and then go to market, because that's how you can sell not to one customer to multiple customers. So that's the second option we've worked it out. And then the third one is a direct selling. In direct selling also, like now we have figured it out, the best way is, apart from our own known contact, the guys who are acting as domain consultant, they have a lot of influences. For example, someone who is an HSE consultant in a large oil and gas company, if you are partnering with him, his suggestion or his recommendations are taken very seriously. So this is what the various channels you need to figure it out. You need to figure it out what channels will work for you and how you can market a product. So this is what we are doing now.
So interesting. I mean, you have an internal champion
Yes.
that you identify, and you also look for a ecosystem influencer,
Yes.
and you start working with them. And interesting that you look for a department which has budgets.
Yes.
So sustainability department doesn't have, but the safety department has.
Absolutely.
And then you start sort of developing this thing. What do you, Akshay?
Very quickly, I just want to add one small point here, which is particularly in our case when it comes to sales and marketing. Firstly, I think majority of the players, when we reach out to them, these are battery manufacturers, right? So what they have to analyze is that how impactful is the product. Why I'm saying this is because accordingly the decisions are being made. Now I'll tell you, our material goes in one battery, which is of approximately 60 kilograms of a battery. Our material is roughly in the range of 15 grams of 60 kilograms battery. That's how small it is. But the impact it is going to create in a battery is huge. Increasing its life by 25-30%, increasing its AH efficiency by another 30-40%. So multiple other advantages we give.
Just for clarity, I mean, this seems to be like a, like a cocaine in the value
Absolutely.
chain. What is a per gram market rate of this carbon nanotubes?
Yeah, so okay, so now this is approximately we're selling at 6,000 to 7,000 rupees a kilo, and this is little different from carbon nanotubes.
Not cocaine yet.
Not cocaine yet. That is what we also call it, is, it's a kind of magic masala which just goes inside the battery and it creates a magic.
Very high density of value.
Absolutely. Absolutely. It's such a small quantity, and that is where, the sales and marketing efforts goes. Why? Because such a small amount of material can make a strong impact on its life, on its performances, on its warranty claims, warranty returns, right? So for us, not even a single decision has come if we are not talking to the owners. We are not even getting a trials to be conducted if we are not getting the permission from the owners. Because the plant head or the R&D head, they're so afraid. They're saying, if something happens because of this carbon, I'm not responsible. So therefore, when we reached out to them, we were not knowing anybody, right? Initially, who we are, when we are reaching out to the owners, they don't know us. So therefore, for us, marketing strategy and marketing and sales happened through veterans. We reached out to big mentors who has around 25-30 years of experience, sit with them, explain to them that, this is the product we have. They took a long time to understand and really went in depth, understood the results, got the certification, saw the results. Only then they supported us. Those mentors.
And they have their reputation to manage.
Absolutely, because if they say to the battery manufacturer, they'll try it. So that's how our things were very different, because otherwise they will not try it out.
Interesting. Thank you. We have one more question there.
Good afternoon, everyone. Thank you. My name is Usha Kiran. I'm from Bangalore, a PhD scholar, working in the lines of impacts of transition towards greener economy or a low carbon economy. So I am studying it at the economic level. And sir, my question is to Mr. Avnish. Sir, you said you are helping the companies in making the process efficient. So in my terms, in my research terms, it is transitioning towards a low carbon firm. Right. So you said that yes, there is a decrease in emissions and GHG emissions, but I also want to know, is there an impact on profitability, stability, or whatever on the companies at the firm level?
Thanks, Susan. It's a good question. Let me just give the background of what does process do, first of all. So you can think of process essentially is nothing but the heart of the entire machinery and the flow. Basically, that's what the process is. It is a set of the process rules that has been written to derive the input and output at every stage. And it's a kind of, it's all concatenated together because output of one will be input of another, and like that it is there. So imagine how complex it is. It had been built on the fundamental science, which is physics, chemistry, formulas, and all. Traditionally, that's how the manufacturing industries has been built today. So when we talk about it now, how do you try to improve or change the way? Today, this is the way it has been working. And whatever decisions has to be taken in real time, that is all left to the operator, which is at the end, who is sitting and he's making certain decisions. It could be one parameter he might be changing. For example, if you take a smelting plant, which is very important, because just to give you, today, if you just look at all the industries of the emissions which happens, aluminium alone is the highest. And if you have just idea about it, what per ton of aluminium leads to the GHG emission is almost close to 1 ton, is almost around 11 to 12% of the emission. So that's the highest concentration. Now, why it happens? Because the entire challenge is it is fully electrified process. It takes electrical energy, and there is always a primary and a backup, because you can't fail. Because if you fail, you have to roll over the process. It's a 32 hours of process, which is phase 1, phase 2, phase 3, where the entire process has to happen. The anode has to be added in the cryolite. They make sure that the cryolite composition and all the cathode anode is built into the right composition, so that alumina can be taken off in the, and whenever you tap into the alumina, again you're disturbing the consistency, and then finally it has to stabilize. Each process is 8 hours long. And if the temperature get disturbed, just to give you the entire process works between 930 to 50 degrees around in that range. If it goes and touches 1000 degrees Celsius, it becomes superheat. Superheat means it can explode. It can be very disastrous. If it goes below 900 degrees, the cryolite can freeze. It becomes a hard rock. You need to take these meltings and then throw it out. This is what the complexity of dealing with this kind of process. So imagine how important is the process at every stage, and how to control that. Today, the traditional SCADA systems are there, which is providing the constant current-based energy, which is only you can tap into the voltage, you can change only the volts, and the rest of the decision is based on the temperature measurement, which you can do in a manual way. It's a dipstick method. If you've seen, they will just put a stick and they'll measure, and little bit of tilt here and there, you will have at least 8 to 10 degrees of variation. Based on that, you will add ALF3, which is another very expensive material, to bring down the temperature. And if you add too much of it, it will come down very low. If you put less, it will further go up. So that's what, when I talk about the process. So this is what we need to control with an intelligent system, which is AI system, which can understand based on the data, the historical data, and the real-time data, and understand those exceptions which is happening in the system, and then decide what could be the best corrective measure. First of all, decide what is the root cause and what could be the corrective measure. If you can provide those correction in real time to the operator, he will take a right decision, because human brain can't do all these calculations in real time. It can only work on the experience. That's where we differentiate. So today we are in open loop system still. because we are still giving it as a prescriptive recommendation to the operator to take those decisions. The decision is still made by him. But in certain cases, like if you see, the world is moving toward closed loop. So we have, at least in the US where we are working right now, we are now moving towards closed loop where our recommendation goes back into these control systems and it sets or resets those control points. That's pretty much what we are doing. So that is what is the whole. So process is the heart. So if you control the process, you will control the energy consumption, you will reduce the carbon emission, you'll improve the profitability. It's all together.
So in this particular case, definitely there is an impact on profitability, Usha. Thank you. Any other questions? For recording and Zoom, you may want to use the mic.
Hi, I'm Sunita Hegde from Bangalore, and my question is to Dr. Akshay Jain. So when you talk about the batteries, as you call it, as pure carbon batteries, right? Where they stand in the circular economy when the lithium-ion batteries are the biggest concern now for the environmentalist?
Right. You mean like whether we can add these into lithium-ion batteries, or whether you think
in the circular economy,
right,
sustainability, how do you...
Does it improve the circularity of the battery?
Got it.
How do you bring
Material
it back?
recovery and all
or
that.
how
Okay.
do you recover it back?
Okay, got your question now. See, first of all, like understanding from Cancrie's perspective, since this carbon is going in multiple batteries, be it lead acid, be it lithium-ion batteries, be it sodium-ion batteries, so it goes in multiple chemistries. Now, how it improves the circularity of the whole battery system?
Does it increase the life of the battery?
Absolutely. And the kind of life it increases, it can go up to 50%. So we have seen these results with different battery technologies. The life can go up to by 50%. Lead acid batteries, lithium-ion batteries, sodium-ion batteries, life has gone up. So the point number one is e-waste is reduced. Now because you would need lesser number of batteries to run for the same number of, for the same number of years, you would need lesser number of batteries, or vice versa. That you would need, same number of batteries for longer life, right? So e-waste is reduced. Point number two, very important. What we have seen consistently over the past 4.5 years is, we as a Cancrie, we are replacing the active material in the battery, always. How much? Up to 5 to 8%. Which means if it is lead acid batteries, we are replacing lead oxides and putting our Cancrie nanocarbons. If it is LFP, we are replacing LFP and putting Cancrie nanocarbons. If it is NMC, again we are removing NMC and putting Cancrie nanocarbons. What it means is that you are actually putting a product which is much more sustainable coming from agri-waste and replacing the active material which is kind of resource like lithium, right? So you are reducing the mining directly by 5%. So in that way circularity is improved again. And third point, very important. When we talk about the circularity or the recycling of these batteries, we also make it easy. So one of the guys who was doing this research, what happens is whenever the battery dies, when you take out the black mass or the electrodes out, you need to recycle it. With our carbons, we have seen that the hard sulfation, what happens inside the battery is much low. Therefore, the degree of temperatures you need while recycling is much lesser. What you need, 1400, 1300 degrees Celsius, 1400 degrees Celsius, you can do the same job in 1100, 1200 degrees Celsius. So in these three ways, we are supporting the circularity. Thank you.
Any final questions? Because we're already 10 minutes over time. Awesome. I think, thank you so much once again. Thank you so much. We have tokens of appreciation, and all the audience, please stay back. We have to do the ceremonial picture for our sponsors. Thank you, Eric, for sponsoring, supporting, and yes. We can do one by one. I'll give it to, yeah. Thank you. Thank you so much. Thank you, Abhishek. Thank you. Thank you so much. Yeah. We'd also like to thank our team from CSCG. Karan is here, Abhishek is there, Romika is here, and Suganya and Kandar. They are outside, but they made this thing happen. IIM Ventures for making this connection, Eric and everyone else. Thank you so much.